Okay, we're going to start going through and discussing lesson 1 in the lab manual. We're going to look at the odd answers, and then I'm just going to answer any questions that people have beyond that. Okay, so I wrote all my answers down here, but I guess I'll probably write them on the screen as well so that we have so that you can kind of see. So we're going to start just going one by one through these. I'm trying to get this set up in a way. I have a really horrible setup for putting things on my desk. My desk just isn't, it's not big enough. Okay, so I'm just gonna number these just like 1, 3, 5, etc. So this is where these start. We'll need a little bit more room for these last three. And 35. I tried to find a digital copy of this so that I could actually put the things on the screen, but it was missing all the figures, which is the part that you care about. All right, so part A. What is the percent error in the following absolute errors? An error of 2.4 centimeters in a measurement of 485 centimeters. Well, to do percent error, you just take the number 2.4, you divide by, what is it, 485, and you multiply that times 100 to get percentage. And the answer you get when you do this, well, what did you all get? What did you get for number 1? 0.49, okay? But there's a rule that they give you about doing percent error, right? And what is the rule about percent error? Yeah, they want you to round it down to how many numbers, how many digits. What did they say in the lab or in the lesson? Just one, exactly. So how should we write this with just one digit? Which is 0.5, right? Okay. So the answer to this one is whatever number that is. That's 2, right? Okay. Any questions? Okay. Number 3. Number 3 says an error of 20,000? 20,000 dyne centimeters in 3.45 times 10 to the 6th dyne centimeters. So what you do the exact same thing again. You just take the small number and divide by the big number. So 20,000 divide by 3.45 times 10 to the 6th. And when you do this, you'll get a number. The right answer here is 2 for the same reason as the previous one. You're going to get some number. Oh, wait, you need to multiply by 100 too. Sorry, this is times 100. And the answer that I got was 0.06, I guess. Is that what you all got as well? And that's choice number 2 as well. Does everyone agree? And again, one digit, unless it starts with a 1. If the first digit's a 1, you can put 2 digits. All right, number 5. This one, we just need to give the number of significant figures in each measurement. So the first one in number 5 is 0.072. Right? Yeah. And in this case, I don't know how you learned this before. Like, I know when I was in school, one of the methods they always teach us is like, if there's a decimal, then you take an arrow and you draw it this direction until you run out of zeros. And as soon as you hit the first number, then you just count the digits after this. Or you can just say, you know, these are placeholders, whatever you want to say. This has, how many significant figures does this have? 2, right? Yeah. Okay. Pretty easy. Those 2 zeros are placeholders. That's all there is to it. Number 7.00. A 3, a 6, and then 2 zeros. How about this one? You can do the same rule. You can basically draw an arrow from the left-hand side, and there's 4 digits here. After that, like after the first digit, there's 4 more digits. These zeros are actually meaningful. So this one has 4 sig figs. That's right. We'll do all these, then I'll ask if there's any questions on any of them. Number 9 is 3.6200. This one is going to have, again, there's a decimal, so you draw an arrow to the left as soon as you hit a real number. 1, 2, 3, 4, there's 5 digits, right? Yep, that's what I got. This is 5. And then number 11 is just 1 because it's 3 times 10 to the 2 cm. And this would just be 1 sig, right? Okay, so does anyone have any questions about any of these?
Yeah, and if for the percent rule for it does apply to the first number, then wouldn't number 2 be just 1%?
Number 2. I did not do number 2. So you're asking to look back at part A, number 2? That's what you're asking about?
Yeah, but since I saw you do what you just did, I just have a feeling that the 1.2 is just going to be a 1%.
So there's a rule for how you do the percent error when the first digit's a 1. When the first digit's a 1, you're going to use 2 sig figs. When it's not, you're going to use 1 sig fig. Chase, does that make sense? So in this problem, because the first digit's a 1, you're going to want to choose the answer that's the right answer that has 2 digits. I don't know which one that is. I'll let you all figure that out yourself. But does that make sense?
Okay, that makes sense.
Okay. Yep. As Ange said, there's a leading 1. Okay. Any questions about the sig figs? So just in general, like, just to go through again how I think about sig figs. Question 3, your answer is 0.57. Okay, Ton, the reason why I put point... Hold on a second. It's 20,000. Oops. It's 20,000 divided by 3.45 times 10 to the 6th, right? And we take that and you multiply by 100. And I got... it's not 0.06. It's 0.6%, right? What did I do wrong? Sorry about that. This one is wrong, is what you're saying, right? Let me just make sure that I didn't write something down wrong. So the actual answer for this one is 4, right? Because this is 0.6%, and the correct answer is 4. Sorry, I just shifted my digit 1 there when I wrote it down, I guess. Okay. Just because the first 3 of these are all following the exact same rule because they all have decimals. Just to be really clear here, what if the number was like 275,000? How many sig figs does this have? Six? No, it's 3. It's 3. So if you have a number like 10, this has 1 sig fig. A number like 100 has 1 sig fig. You can keep adding zeros on here. It's not going to add you any significant figures. The rule that I use for these ones is when you don't have a decimal, you do the little arrow thing that I said, and you basically just draw an arrow in this direction until you hit a digit that's not a 0. That's the method I learned. I don't know what you all learned, but whatever. Okay, so just to kind of like cover some situations that we didn't cover. Okay, we're on number 13. Okay, so we have a measurement, and the measurement is 7138.2, and we're supposed to cm, and we're supposed to figure out how we should write the measurement if we measure it to 4 sig figs, and there's all of those different options there. So I would argue that there's 2 different ways to write this using 4 sig figs. You can either write it as 7138 or 7.138 times 10 to the 3. And both of these options are available, I believe, right? Yeah, this is option number 2. And this is option number 1, right? So I believe the best way to say this answer is that the correct answer for 13 is 2 or 1, but this one is better technically. Because if you want... there's one of the rules they give you at the very beginning, right? What do you all think? Is either one of those answers better than the other one? Or do you all think those answers are exactly the same? I had this weird memory doing this in the past that if you can, you're supposed to write it in scientific notation. Do you all remember something like that from the lesson? Is that right? It says something like that, right? I'm trying to remember where it says it, but... Anyway, either one of those works. I'm not going to spend too much time on that. Okay, so number 15. We have the same number, 7138.2. And with 15, we need to write it to 2 sig figs. And for 2 sig figs, so if we want to write this with 2 sig figs, let's choose a different color. We want to write it either as 7.1 times 10 to the 3 cm, or the other option would be to write it as 7100. And I think both of these answers are on there too, right? This is answer number 7, and this is answer number 10. In this case, I can definitely say that this is a better answer. So I think the answer number 15 is in fact 10. Kind of like, or, what, 9? Why did you say 9? Oh, okay. So I think the answer is 10, which is 7.1 times 10 to the 3. And technically you could choose 7 too, but I think that it kind of tells you not to do this. Like, if you can, it tells you to avoid lack of clarity, because it's possible that someone might look at 7100 and think that it's 4 sig figs, but it's really only 2. It's also possible that these zeros, they technically could be significant, right? And if you wanted to ensure that you wrote those zeros as being significant, you'd write it as 7.100 times 10 to the 3. Then they would be significant. So to create more clarity, you would just write this when you only want to use 2, right? Because 7 is kind of like not as descriptive. All right, that's kind of nitpicky, but... Okay, any questions about those? Okay, number 17. How many significant figures should you write to express the following measurement? So in 17, the number is 7.364. And what are we supposed to do? Just how many sig figs? So it's 4, right? So they're just kind of showing you how the way that they're going to ask these questions. 19 is a little more tricky, I guess. 19 says a measurement lying between 6,000 and 8,000. So the measurement would be 7,000, right? And it's like 7,000 plus or minus 1,000, right? That's basically what their measurement would be. So this is just 1 sig fig, right? Because if you go from 6,000 to 7,000 to 8,000, this is grams, then that basically implies that your scale can only read increments of thousands of grams, right? It can't tell the difference. It doesn't know what 650 grams is. Your scale can't actually read 650 grams in this case. So that means the only digit that's going to matter is that first digit right there. So this is 1 sig fig. Any questions about that? Okay, these are mostly pretty easy. The hard ones are these last few here. We'll get to those eventually. 21. What percent error is implied by the following measurements? Okay, so if you have a measurement of 20 cm and you don't know what you're supposed to use for the error, you're supposed to just change the last digit. So this is going to be plus or minus 1. So that means that the percent, what percent error? Yeah. The percent error is going to be 1 divided by 20 times 100, which should be 5%. And I think that is number 4. Option 4. For 23, the number is 0.000. Why did I put a 1 right here? It's in the lesson, Ton. I mean, you can. I don't know if you read it or not, but somewhere in the lesson it says if nothing is given for your absolute error, you're supposed to just assume it's the last digit that you change, basically. I don't know where it says that. Somewhere in here it says that. Just gotta read all the words. You'll see it in there somewhere. All right. The next one is 0.00. So 4 zeros and then 200. Okay. So it's basically. I'll write it out the way it is. It's kind of annoying to write this number out. How many digits? So it's 4 zeros in front, and then a 2, and then a 0 and a 0. So this is going to be plus or minus. This is going to be kind of stupid. 1, 2, 3, 4, 5, 6, 7. Yep. This digit is the one that's changing. So that's our absolute error. And then we can basically, I'm not going to write all these out again, because really what we're going to be doing is just basically 1 divided by 200 times 100. Because if I take this entire number, 0.0 whatever 1, divided by this number right here, then I can move the digits like 7 places to the right, and then I'll get this basically. Okay, so this is going to give us a percentage of, it looks like half, 0.5%, which is option number 3. Is that what I wrote down? Yeah. Around 23. Okay. Any questions?
Yeah, I think I have a question.
Go ahead.
So, I understand the 4 zeros for the 0.01 thing, but where did the other two... Oh, wait, the other 2 zeros came from the 200, right?
On 23? Yeah.
And then the 1/200 thing. It's, Oh, never mind. I can see it.
You figured it out?
200. I think I did. It's just I was just using my eyes.
That's all that I did. I just did this in like this. I just didn't want to write this whole thing out. Okay. 25. This one's really weird. Okay, it says a measurement between 59.90 cm and 60.10. So the number that fits between these two would be 60.0, right? The question is, do I add another 0 here or not? What do you all think? Should I leave it as 60.0, or should I add another 0 on here?
I think you should.
I think you should add it.
So let's think about what such a scale would look like. So this would be a reading that you might get off of like a meter stick, because a meter stick measures centimeters and then millimeters, right? And on a meter stick, what you would have is you'd have 60 right here, and then you'd have evenly spaced millimeter measurements, right? Until you got to the next one. So this number here would be 59.9. The next number above that would be 59.8, right? The next digit down here would be 60.1, right? So you really have to wonder about where this 0 is even coming from, right here. Like, where would this 0 come from? And I'm not saying this because I'm imagining a meter stick. I'm saying it because how can you say that there's a measurement between 59.90 and 60.10 and no other measurements in between them, right? Like, where is, for example, and what's a number that could fit inside of here? What number could fit between 59.90 and 60.0? What would be the number in between those? Like, right in between. Right in the middle of those two numbers. 59.95, right?
95, yeah.
59.95 would be right there. And in between these, you would have 60.05, right? But according to all you can go off is what it says. It says a measurement between 59.90 and 60.10. So since these two numbers are not included between them, and all the other, there could be more too, right? You could have 59.94, 59.93, right? If you actually want to include this last digit right here, then you need to be able to fit these other measurements inside of here, but those measurements aren't included. This is the only one that lies in between, off whatever scale they're using. So I'm pretty sure that the right answer to this one is 60.0 plus or minus 0.1 cm, which is option 2, right? It's kind of confusing, right? I don't know if you understood my logic, or even if I explained it in a way that was comprehensible. But that's the right answer. Do you all have any comments about that? Does anyone disagree? Why isn't it the other one? Well, it can't be 0.01, right? It can't be 60.00 plus or minus 0.01. That's not one of our options. And for that one, Joanne, it would say a measurement between 59.99 and 60.01. If that's what it said, then the answer would be what you said. This would be plus or minus 0.01 for this last digit right here. The reason why this problem is even in here is to kind of break through a common fallacy that students make, or a common mistake that students make, which is sometimes students, when they're making measurements, will include extra digits they shouldn't include. And that's what's happened here, is that these digits are not meaningful. This digit is meaningless, and this digit is meaningless as well. And the reason why it's meaningless is because you go straight from 59.9 to 60. You didn't do anything with that digit, right? You didn't go to 59.91, 59.92, or even 59.95. You went straight from 59.9 to 60.0. So what was the point of this last digit, right? Does that make sense? Like, why did you include this last digit here? Obviously you guys didn't do this, but like, this is something that students do pretty commonly, is they include extra digits that they didn't actually measure. So that's the reason why this is the right answer. Does that make sense? This is probably like the least intuitive one on here, but it's designed to kind of like, challenge the way that you, like, you're all trying to become engineers, scientists, computer scientists, all this kind of stuff, right? And accuracy is really important, and this one really just kind of challenges you to think about what you're reading, to like, I guess what I'm saying is, like, you have to be skeptical to be a scientist, and so you have to sometimes think maybe the information that's being given to you has been measured in a proper way or something like that, and this is an example of that. Okay, 27. So this one, we have a measurement between 920,000 and 940,000. Okay. So there's only one number that's going to fit inside of here, and that would be 930,000. So that's our number. And we need to express that properly. So this can be written, we only have two sig figs, right? So ideally we want to write it using scientific notation, which we would write as 9.3 plus or minus 0.1 times 10 to the 5, I think, right? Yeah, times 10 to the 5. So that's going to be our answer. And I think that... Did I write down that there were two answers for this one? No, I didn't. This is the only answer that makes sense, I think. Maybe I'm crazy. You all can tell me if you found another answer that makes sense. And I think this is option number 6. Is there another one on there that actually that works too? Maybe number 2, right? Two is the same thing, right? Do you all agree? The other one is 930000 plus or minus 1000. That works too, right? Yeah? No? What do you all think? That's our number, 930,000. Oh no, it doesn't work because it's supposed to be. It would need to be 10,000. It would need to be 10,000, wouldn't it? This would work, right? Sorry. Yeah, I was wrong. This would work, right? But that's not an option, as far as I can tell. Okay, so then this is the only answer. That's the only one that makes sense. Some of these might have multiple answers, but in general, when you get multiple answers, you're going to default toward picking the one that has scientific notation. Okay, so let's get on to the hard ones, the really hard ones, which is reading these calipers. Okay, so the lab manual goes through an explanation of kind of like how you want to calculate these, and I feel like the explanation is really, really complicated. It's good. It's a good explanation. It teaches you an algorithm that will work for any micrometer or any caliper. But I don't know. It's kind of terse. The language they choose to use is kind of. It might not be something that when you read it as a student you might not have understood all the details, and it may have just confused you. So I'll do my best to teach you how I read these things. Now, I'm going to warn you that what I'm going to tell you to do is it's really simple, but I'm just going to warn you that you might miss some of the details if you're not paying attention. So just stay with me and try to pay attention to what I say. Like, don't miss any of the words. Just pay very close attention. Okay. So the first one, question 29. You have a I don't know, centimeter ruler of some sort, or calipers, and it's divided into half centimeters, basically. So it goes 2, 2.5, 3, 3.5, 4, etc. The first thing that you do in reading calipers is you look at where the 0 is on the lower scale. That's your measurement, basically. That's where the measurement comes from. So in this case, the 0 is just to the right of the 3.5 mark. Would you all agree with that?
Yes.
Okay. So that's the first thing you write down. You just write down 3.5. That's what you do. You just write it down, right? And then you write plus. What the caliper does for you, what the secondary scale does for you, is it can measure exactly how far to the right you are of the 0.5. You can see that the measurement in this case looks to be between 3.5 and 4. And it's closer to 3.5. So if I was to make a guess, I would say it looks like the answer that we're going to get is going to be something like 3.6 or 3.7. Would you guys all agree with that? It's a little bit more than 3.5. It's not quite 3.8. That's what I'm trying to say, right? It's okay. This is a really important thing to remember when you're doing these type of measurements, whether you're actually doing them or we're doing this exercise. You can use your brain to figure out what you think the answer should be before you get the answer, and this will help you to not make mistakes. So we think the answer should be approximately 3.6 to 3.7. That's what we think. Now, how do we get a better answer? Well, the next thing you do is you try to you look at the bottom scale and the top scale. There's two different scales, and they're like teeth, right? They're like teeth. And if you look at the way that they line up, there's always going to be one of the lines that basically is a straight line between the upper scale and the lower scale. So you have to just kind of look along the bottom and along the top. You're looking for two lines that perfectly meet up. So which line, as measured from the bottom scale, do you think lines up?
Where the 4.5 mark is?
Yeah, the second one.
Yeah.
The second.
Now here's the thing.
4.5.
Okay, here's the thing. We don't want to think about it like you just said, Chase. We want to look at just the bottom scale. We don't care what the number on the top scale is for this part. We only care about the bottom scale. So, which mark on the bottom scale lines up? I agree it's the 4.5 mark on the upper scale.
The bottom one is 2, right?
It's 2, right? 2. The number 2. That's the next thing you're going to write down. 2. It's the second mark, right? So right here, where we said 3.5 plus, you write a 2. Now, that's 2 out of how many on that scale?
There's 6 of them.
There's 6, right?
The bottom.
Okay, so that's the next thing you write down here. The bottom is 6. So 2 out of 6. And now you need to take this. So we're 2/6 of the way of what? This is the thing you have to think about. It's 2/6 of what? Well, it's 2/6 of the distance between the markings on the main scale, which is half a centimeter, right? So you multiply this by 0.5. Okay? I'm going to write below this what all these things are, which is kind of what the lab manual does, but this is the mark. I don't even know how to write it, but I'll just go through it again. 2 was the number on the vernier scale. I'm going to call the bottom scale the vernier scale. 2 is the number on the vernier scale. 6 is the total number of markings on the vernier scale. And then this is whatever the smallest measurement on the main scale is. Which, would you all agree that that's half of a centimeter?
Agree.
Okay. And then that's the answer. Whatever this gives you, whatever you get from all of this is the answer. And what I got when I calculated this was 3.67 centimeters, which is consistent with what we thought the answer was going to be. So multiply all that out, that's what you should get for your answer. And that's it. That's how you measure. That's how you use these calipers. It's really, it's tricky at first, but when you learn how to use these things, it's really powerful because you can measure extremely accurate distances with these things, which is really valuable if you're working on things that need accurate measurements. Okay, any questions about 29 before we go to 31? That's not that hard, right? It really isn't.
Yeah, you just take where the first measurement is and then add it by where the two things line up perfectly straight, multiply by the measurements.
Yep, that's right. Okay. Okay. So let's go on to 31 then. Can you leave the answer as 11 over 3? Probably not. Now, in this case, no, I would write it like this still. Yeah. Sometimes it's okay to write fractional answers. I think probably question number 30 and 32 might have fraction. Actually, I don't know about 30. 32 though, your answer you might want to write it as a fraction. I don't know.
Yeah, I think 30 has a fractional answer too.
Yeah, maybe so. 30 is going to be 2.0 and then 3 over 7 times 1 over 6 or something. You know what's going to be a lot easier for me is if you don't write it in fractions and instead you write it in decimals, but 32 I can see a reason why you would write it in fractions, because it looks like the scale is divided into sixteenths probably. Is that sixteenths?
Yeah, how would you find the smallest measurement for that? Like
for what? For 32?
Yeah, 30.
You count the number of markings and then divide an inch by the number of markings there. So there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So it's 1/16 of an inch. That's what because there's 16 markings, right?
Oh, okay.
Okay. Let's do question number 31. 31 might be the easiest, so I'm tempted to do 30 instead because it's so confusing, but whatever. We're going to keep doing the odd numbers. So for 31, we look at where the 0 is, and in this case the 0 is at about 3 something, 3.0 something, right? And now we're also going to think about approximately what our answer is. To me, it looks like when I look at this, the answer is going to be something close to 3.08, maybe something like that. Would you all agree? Looks like.
Yeah, it's close to 3.1.
Okay, pretty close to 3.1, but obviously less than 3.1. So if we got an answer over 3.1, that would be a reason to check our work, because it would be wrong. So, first thing that we do is we look at where the 0 is. The 0 is at 3.0, and then we put a plus sign. The next thing we do is we look at the bottom scale, the vernier scale, and we look at where it matches up with the upper scale.
I see it matching up where 7 is.
I agree.
Completely straight up and down.
That's exactly right. You're looking for the place where the line is straight up and down. I'm just going to write 7, and I'm going to have everybody look at it and just verify for yourselves that it is on the 7th mark. Can everyone see that?
Agree.
Okay. And again, what you're looking for is the place where the bottom scale lines up with the top scale. And you look at the bottom scale, you look at the number, you write it down, 7. And then what do I divide this by?
10.
10. And you got that from the vernier scale, right? There's 10 markings. It goes from 0 up to 5 to 10.
Agreed.
So then we multiply this by the divisions on the main scale. So what is the smallest division on the main scale in this case?
It's like 0.1 centimeters.
0.1 centimeters, right? So we multiply this by 0.1, or 1 over 10. And this math is super easy to do because this ends up being 7 divided by 100, which is 0.07. So we get 3.07 cm. So there we go. Number 31 is what the actual calipers of the lab look like. When you actually use the calipers in the lab, this is the real scale. This is what it looks like. Okay. 33. So now we're on to micrometers. Micrometers are a little bit different, but they're not that much different. The way in which you do the calculation is pretty similar, actually. The difference is just that you've got this rolling micrometer thing. Okay. So when we look at 33, once again, there's no 0 here for us to like look at where it lines up, but the place where the sleeve, you could call it, I guess, starts, that straight line that's a little bit to the right of 12.5 millimeters, that is the place where you're taking your measurements, right? So in this case, the first thing you're going to write down is 12.5. Does everyone agree with that? Because you can see that it went from 9 to 9.5 to 10 to 10.5, from 11 to 11.5, and now we're at 12.5.
Agreed.
Okay, the next thing that you have to do, this is even easier, because now all you need to do is to look at that sleeve and see where the sleeve lines up with the kind of like that horizontal line from the main scale. And in this case, it looks like it lines up with the 7th tick on that mark. Would you all agree with 7?
Agree.
And then, same thing as before, we're going to divide this, and we divide it by the total number of markings on the sleeve. And it tells you below that there's 50 divisions on the sleeve, right? So you just divide by 50. It's 7 out of how many? 50. And what is that a percentage of? Well, that's a percentage of the divisions on the main scale, once again. So what's the smallest division on the main scale in this case? Just 0.5, right? That's it. Since this is a half. Yes.
Where did you get the 50 from? Like, did you like multiply the 10 and
50 divisions? Stop. Below
Okay.
this, on question 33, it says 50 divisions on the sleeve. So that sleeve
that's
has
silly.
50.
Oh, that's silly of me. Sorry.
That's okay. All right, so this is also easy calculation to do because 0.5 is a half, and 2 times 50 is 100, so the answer is going to be 12.57. And this is actually in millimeters. Micrometers tend to give you 1 extra digit of accuracy compared to calipers, right? This has 4 sig figs. Those have only 3. And this measurement, if we put it in centimeters, would be 1.257 centimeters. So you can tell that this has more accuracy, basically, than the calipers. And micrometers are, they're really good for giving you super precise measurements. Any questions about 33? Okay, 35. 25 divisions on the sleeve, 1 revolution for each division on the main scale. Okay, so in this problem, what am I going to write down first?
Well, when I looked at the thing, I divided like what's between 1.5 and 2.0, and then it was 0.5, and then I divided that by 4.
Mm-hmm. Yeah.
So, and then I multiplied that by 3, and I added it, so I got around like the 2.375 mark.
I agree. That's exactly what I got too. So just to repeat what he said, because that was 100% right, to figure out what the division on the main scale is, what you said you did, Chase, is you took 1.5 to 2 is half a centimeter.
Yeah, and then I divided that by 4.
Yep, you divide by 4, which gives you basically an eighth, right? So the divisions on the main scale are basically an eighth of a centimeter, or 0.125 centimeters, right? Let's remember that. On the main scale, so main scale is divided by 1/8, which is equal to 0.125 cm. Right? That's our main scale division. right there. And so yeah, multiply this by 3, you said, because there's 3 tick marks, because it goes 1.5, 2.0, and there's 3 markings. So that would be 2 and 3/8, right? Or this is the same thing as 2 and 3/8. They're the same thing, right? Okay. Plus, the next thing we need to write down is the marking on the sleeve that lines up. What is that going to be in this case? This one's kind of tricky. What is the mark?
Looks like 10. Looks like a 10.
What do other people think? It's not 10. But I understand why you think that.
Oh, silly me, 8.
It's not 8.
Oh.
I was gonna say 8, but I don't
we're
know.
looking. So we're looking at the sleeve, right? We're looking at the sleeve. How many total divisions are there on the sleeve? 12 is not the answer either. How many total divisions are there on the sleeve? What does it say? It says 25, right?
Oh, 25, yeah.
Okay, so if you have a scale that rotates around in a circle and it goes from 0 to 25, the scale is going to go from 0 probably to 5, and then 10, and then 15, and then 20, right? And what will the 25 look like on your scale? Does that question make sense? It's a circular scale, right? So if it starts at 0, and then it goes 0, 5, you keep rolling, and you see 10, and then you see a 15, and then you see a 20. What's the next thing you're going to see? Are you going to see a 25?
You're going to see a 0.
You're going to see a 0, exactly. That's right, Andrew. So that 0 is actually 25, right? That 0 actually represents 25. So what's the measurement?
4?
Nope.
Oh, I guess it's 5. Huh?
No, it's rotating the other way. You're all thinking it's rotating. It's 23. It's 23.
Oh, it's rotating. Going up. Okay.
Yeah, they all rotate the same way. This question is just. This is actually a really good question because this exact thing will always happen when you use these micrometers. If you do enough measurements, eventually you're going to get measurements like this where you get confused. So this is a really good example. It's why it's the last problem too. This is an extremely, extremely common thing that happens when people take these measurements. So it's actually 23 out of 25.
Gotcha. I see it.
Yeah. Very confusing. And again, we have to take this 23 out of 25, and we need to multiply by the division on the main scale, which was 1/8. So I'll just multiply by 1/8 here. And add up all this stuff together, and you're going to get... This is another part about this. If you just put this in your calculator, you're going to get 2.490... Sorry, 2.49. But if you look at how detailed the measurement can be, we should get another digit. So the actual correct answer is 2.490, and these are in centimeters, right? Yeah, cm. That is the right answer.
So the whole thing with the 23, you must have so you said 25 divisions, like after you said something like after hitting 20, and you said something like 0 representing 25.
Yeah, it does. 0 represents 25 in this case.
Oh, I can see that.
Yeah, that's it. Okay, so that's all the answers. Now, if you all do have questions about the even number problems, I'm going to stop this recording, but I will answer questions about the even number problems off of the recording. Can I go over the fraction number for 34? Yeah. So okay, again, I'm gonna end the thing right now, and then I'll answer questions. Okay.